For the last section in this part, we're going to solve the inequalities by graphing. So we have x minus 4y is less than 4. So the first thing we want to do is solve for y and get it in that form that we were just doing, the y equals mx plus b. It's an inequality, but we'll talk about that in a minute. Just get it solved for y first, and then we'll deal with the inequality. So I've got negative 4y is less than, if I subtract x, negative x plus 4. Divide both sides by negative 4, and you still have to flip. If you multiply or divide by a negative, you have to flip. So I'm going to have y is greater than. Negative 1 divided by negative 4 is positive 1/4 x. 4 divided by negative 4 is minus 1. So to graph this line, so ignore the fact that it's an inequality for just a second. We're going to graph the line first. My slope is 1/4, and my y-intercept is 0, negative 1. So I'm going to plot my point. Well, I guess I shouldn't say we're going to totally ignore the fact that it's an inequality, but let me plot my y-intercept first. So 0, negative 1, I'll get my 2 points that I'm going to graph. 0, negative 1. Slope of 1/4 means I go up 1 and over 1, 2, 3, 4. And then I can connect it. But for an inequality, instead of just drawing a line, if it is a strict inequality, you need to do a dashed or a dotted line. And if it has an equal to, then you do a solid line. So you have to pay attention. If it's strict, make sure it's dashed or dotted. If you have greater than or equal to, it's a solid line. So for me, for this one, it's a strict inequality. So I'm going to do, I really can't do straight dashed lines. Something like that. So there's my line, dashed, because it's strict. Now the easiest thing to do to shade these, because of inequalities, just like on number lines, you don't just put a point at, you wouldn't just say, negative 1, you wouldn't put a point at negative 1 and be done. You have to shade to the left or to the right on a number line, or in between, or whatever the case is. For these, if you always have y on the left, this tells you which way to shade. Greater than, you shade above the line. Less than, you shade below the line. So if you do greater than, that means shade above. That's the way I always do it. Some people prefer to plug in test points to see, which is fine if you want to. So you pick a point that's not on the line. If 0, 0 is not on your line, that's the point you want to pick, because it's easy to plug in zeros. So if you pick 0, 0, I've already shaded. It should work because I've shaded it. It's included in the shaded part. So if I plug in a 0, you can plug it in here. You can plug it back into the original. It doesn't matter. 0, 0. So 0 on the left is less than 4. Is that true? Yes. So I shade the region that contains that point I picked, which was here, which is 0, 0. So I still shade up above the line. But like I said, me personally, I get y on the left, and then if it's greater than, I shade above the line. If it's less than, I shade below the line. The only time that doesn't work is if you have a vertical line, like on this one. X is greater than or equal to 1. It's solid because it's equal to. And if it's a vertical line, you got to go right and left, just like on a number line, instead of up above or below. So greater than 1, greater than or equal to, solid line. Greater than would be to the right. This one, if you did a test point, 0, 0, it's here. It's not part of your shaded region, so it shouldn't work. 0, greater than or equal to 1, that's not true. So you shade the region opposite 0, 0. So you cannot have 0, 0 in your shaded region, so you'd shade over here. But like I said, personally, if your variable's on the left, doing to the left or right or up above and below is usually quicker and easier in my opinion. But however you're comfortable, if you like doing test points, that's fine. So if we have negative x plus 5y minus 10 is less than 0. Again, we're going to solve for y. So I'm going to add x and add 10 to both sides. So 5y is less than x plus 10. And then I'm going to divide both sides by 5. So y is less than 1 divided by 5 is just a fifth x. 10 divided by 5 is 2. So this time my slope is 1/5 and my y-intercept is 2. 0, 2. So to graph this one, scoot this down a little bit. So I'm going to start out at my y-intercept, so 0, 2. And then from there, my slope's 1/5, so I'm going to go up 1. And then over 1, 2, 3, 4, 5. And I'm going to draw the line, and again, you need to pay attention. If it's strict, you have to do dashed or dotted lines, and if it's equal to, you do solid. This one's strict, so I'm going to do dashed. And again, for this one, if it's less than, y is on the left, so if it's less than, I would shade below the line. If you want to check it, you can check it if you do plug in 0, 0 again, because 0, 0 is not on your line. The only time you can't use 0, 0 is if it goes through the origin, then you got to pick a different point. But if you plug in 0, 0 to whichever equation, the original or this one, you'd have 0 is less than, this is gone, 2. 0 is in fact less than 2, so that's true. Or you could do it up here, this is both gone. Negative 10 is less than 0, that's also true. So you need to shade the part that has 0, 0. So just make sure on those, you, usually the shading's correct on people's graphs. The part they forget is to do the dashed line versus the solid line. So strict, do dashed. If it had an equal to, you'd make a solid line.